MPLS with RouterOS on practice by Alex Vishnyakov.
Hello to everyone. Thank you. I'm sorry my voice can jump because I was sick for 4 days. So it's 2 days before I had no voice at all, and now my voice is a bit better. But yesterday I was speaking like Don Corleone, that, and I was afraid that I'll start talking with the voice of Don Corleone about MPLS. Can you imagine it? So it's such a funny story. But it's not, so it's good still. I hope that you enjoyed your stay in Prague and Mikrotik conference. This is the last presentation, guys, and who is still alive and who is still not sleeping? Oh, a lot of people. Good, that's good. And who is interested in MPLS? We had no topics about MPLS in this presentation. Who has some experience with MPLS? Who knows what MPLS is? Oh, also, almost the same amount of hands. That's good. So I will not tell you any boring stuff about how to configure routers to work MPLS. You can join training and you can learn commands there. I will just show you the real practice examples, how we did it during last year. So I want to share with you my experience and how we were implementing the MPLS in our network of company Skywire Technologies in South Africa. First, few words about myself. I'm a Cisco certified in different areas in the professional level. Also, I work a lot with Linux and FreeBSD. And of course, I'm a Mikrotik trainer, actively training people in Czech Republic and sometimes in Russia, and now in South Africa. Main areas of my main fields are BGP and dynamic routing, MPLS, and security. Currently, I'm working as an ESP network team leader in Skywire Technologies, South Africa. And I worked there for the last 1 year. On the last MUM, I met people and I got opportunity to go to South Africa working there. When I went there, of course, as many of you, I was thinking that Africa is about wild animals and maybe city of Cape Town and no internet. So that's the first thing is true. There is a lot of wild animals. You can come to South Africa and go to special places and find these guys there, but it's a lot of wireless internet there. So I'm on the highest tower of Hillbrow, which is 270 meters high, and we have a lot of our equipment there. That's the top. So you can imagine if I stay on the top of the tower, where stays the guy who is making the photo? Good. So serious things. Network description of Skywire Technologies. So we provide services only to businesses. We do not have private customers. We have presence in all big cities in South Africa with more than 1,500 kilometers wide network. Because South Africa is a quite large country. And we have over 1,000 of mid-size and large enterprises which we connected to our network. Also, we provide last mile service for the second largest telco in South Africa. So it's a large telco company which has own fiber network, but somewhere they do not have fiber and they ask us to bring the last mile through wireless to them and provide them layer 2 connectivity. And they provide services to end users. Also, we have many of small ISPs who are using our network, and we provide transit of IPv4, also layer 2 and BGPv4 for these customers. Because we work with corporates, they request VPNs from us, and we give them these VPNs. And we have over 100 really big towers, a lot of small towers, and hundreds of access points, and a lot of point-to-point links. Before we started implement MPLS, we had several tasks and goals. I can divide them into 2 parts, the bold texts. The first part is to separate somehow transit and these last mile services, which we provide for our partners who are not our end users, but other ESPs. So we need to provide hundreds of layer 2 tunnels for the last mile service. We need to provide layer 3 transit and BGPv4 transit. And we need to separate this traffic, separate the routing and everything. So we'll separate it from our own customers. And the second part is our own customers. We need to have some very good, smart, scalable solution for VPNs, which will not depend on the vendor. And we also need to separate our routing of internet, of voice and management. So, and we need to use traffic engineering. I will tell it later, of course. So how to solve these tasks? The first, it's not very nice, but I hope you can see that there is a large ESP network peering in one point, and there is their customer. So we bring the layer 2 tunnel through our topology, like 5 hops, for example, and we need to provide to that large ISP last mile service with a layer 2 tunnel. What is the solution when you have routed network, or if you have switched network, some of you? In routed network is the Ethernet over IP, so we can bring layer 2 over it, L2TP tunnels, or if you are switched, you can switch the VLAN through the whole your infrastructure, but I can tell you that it's a nightmare. Don't do this. Of course, the solution is MPLS. Let's build the MPLS cloud, and with the MPLS, can provide with this layer 2 tunnels. It's a VPLS, LDP based, what we are using. We can use also multi-protocol BGP, but we decided to use this solution LDP based. So you will see that in our example, in our practice, we tried all possibilities of BGP, of all possibilities of MPLS, multi-protocol BGP, LDP. Something was working, something not. I will explain it during my presentation. So the next task was, we need to separate layer 3 traffic, I mean in terms of routing. How to do this? We have a customer, so some company which is routing their prefixes through our network. How we can do this? If we put it statically, nightmare. If we put it to OSPF network, it will create a lot of routes and prefixes that we do not want to have inside our core, inside our backbone. So for this, solution with MPLS is VRF, all layer 3 tunnels. Multi-protocol BGP technology is used for signaling here. And here is a small jump, but it also is from the same field. We need to provide layer 2, layer 3 tunnels for other ESPs, and we can use also the same topology, and we will provide multi-protocol BGP tunnels. Layer VPLS or layer 3 VRF tunnels. And the last tasks will be solved because everything is about layer 3. Everything will be solved with VRF and multi-protocol BGP. So I think that it's quite clear that we have to use MPLS. And MPLS is the solution. One common, vendor-independent, strong technology for tunnels and for all this, to solve all these tasks I described before. There are 3 nice pictures. The first, what customer thinks about MPLS. When you come to customer and say, I want to sell you MPLS, it's nothing for him. He just needs the internet, the cable, and connection from headquarters, for example, to the branch, nothing more. What ISP owner thinks about MPLS? When you approach someone who already owns his ISP, he thinks that MPLS will solve everything. So this is some magic technology which will do everything instead of him. What vendors think about MPLS, and this is really important, and we are on the vendor conference. But Mikrotik is not the case. They think that it's a quite expensive technology and they can make money. So when we were choosing our provider edge routers, and we had to build, like, let's say for the beginning, 80 provider edge routers, and buy and put them to the existing topology, we were thinking about who is the good vendor. The company, the name we do not say here, the first one, very expensive. The Juniper I can pronounce, not cheap at all. And Linux and FreeBSD, they do not have stable implementation of MPLS technology. And Mikrotik has a nice solution in cloud core routers, which I like so much. And also that's why I made this presentation. Before we started to implement MPLS on Mikrotik, and in our network, we had made research and we were reading a lot of things. We got trainings and we got this output at the beginning of last year that Mikrotik has a very stable VPLS implementation, layer 2, and it has a stable MPLS switching itself. So the MPLS switch labels very good. And layer 2 tunnels, both LDP based, multi-protocol based, work fine. So this was proved also by this gentleman. Recommend to download their presentation. My friend Thierry Ware from France, he was making presentation last year where he was showing his large network in France built on the Mikrotik VPLS with traffic engineering. Everything works fine. He's very happy. You can even find him here. And Thomas Kirnak from Slovakia, he made a nice presentation about how to make VPLS backbone and provide PPPoE services over it. And Pat Harris in 2014 made a nice presentation about VPLS implementation in a large US sugar company on the wireless environment. But there we had still a lot of questions about VRFs. So layer 2 tunnels are clear. What about VRFs? There is a nice topic on Mikrotik forum which you can read. There is a history of several stories, the bugs, issues of VRFs, and it was still continuing fixing, and we were still not sure. So that's why we decided to take some cloud cores, install them to our network, and test it and run it. After we finished, after 1 year, what is the output? So this is my personal output. So you can disagree, of course, you can agree, or you can ask me after presentation and I will describe all these points. The VPLS tunnels, L2 tunnels are very stable, both multi-protocol and BGP based. Just be careful with MTU on switches when you run, because your frame, layer 2 frame is really big, and sometimes you will lose neighborship because some switches has problems on different ports. So this is just an experience. And what about VRF? By itself, I think that VRF is stable in the latest RouterOS version, so we don't have any big issues with the VRX itself. So there are some small things like this too, which is the PPPoE cannot bind to VRF dynamically, so that's why we do not use PPPoE, we use DHCP. Inside VRF is not shown, so we do not propagate TTL, do not show stars to our customers. But there are several still like bigger issues, which is, for example, route leaking. We were not able to make it working properly, so we put additional routers if we need to leak from one table information to another table. So we put additional router for that case. But when we already switched to the new topology, we removed these routers. Another issue which is important to know about it is the route withdrawal. Sometimes VRF has a static dynamic routes withdrawal problem. So it means that if you remove the route from the VRF table, from the table of interface, I think, and it doesn't disappear from the VRF. So it's still appearing on your BGP neighbors. So if you remove it from one router, it still appears on routers it's advertised. But it's not always, it's just sometimes, and I was not able to find exactly what is the reason. So that's why we do not redistribute dynamically to VRF. So we do not redistribute dynamic protocols. We redistribute connected routes. And when you redistribute connected routes, it works well. I will show it on topology later. And when we redistribute static routes, we are very careful with their removal. Static route, we checked several times that it was removed from all dynamically propagated routers. And there is a small issue here that VRF BGP bus selection has sometimes issues with choosing right BGP metric. So instead of using local preference, we are using distance manipulation. So more detailed explanation, write me the emails or come to my trainings. MPLS topology, so our topology, but if we, even with these things with VRFs and some issues, we are able to build a quite stable network if we know about it. So when we know about something, we are prepared. So how we build a network? MPLS. So on all of our big towers, we have a provider edge routers, which are part of MPLS infrastructure. And customers, they are connecting through bridge mode. So they are on layer 2 brought from access point to provider edge router. So we do not make /13 routing and a lot of routing on access points. So we simply bridge it up to here, up to provider edge. Bridge the customer to provider edge. Provider edge is connecting to the core of the network, and the core of the network has this technology. So when you will use MPLS, when you will implement MPLS in your network, you will have to, I recommend you to use OSPF, because it's for distributing information between routers and to send information about connected routes and loopback information. Then you need a label discovery protocol to distribute labels of MPLS. And then you'll need BGP for creating of tunnels and MPLS stack switching itself, of course. So this, let's say, 4 technologies are used in core, and this how we bring customer to the provider edge of MPLS. And when we bring customer with this way, it means that we do not redistribute a lot of static and dynamic routes to the VRF. We redistribute only directly connected. And with directly connected, VRF works very well. No issues at all. So let's implement MPLS. I will not show any comments, I will just show you screenshots. So I was telling you some story now, and I want to prove it and show you that it's true. It's not something that I was just painting and drawing somewhere. So first step, bring customer on layer 2 to provider edge router, what we did. The second, we activated OSPF on distribution and core layer. We activated LTP, as I told, MPLS tags, so MPLS is enabled. Then we built BGP, but instead of full mesh of BGP, we will build BGP with route reflectors. And this is just a small step, multi-protocol BGP activation of Mikrotik. And 2 last steps is creating of tunnels itself. L2 VPLS, LDP based or multi-protocol based, multi-protocol BGP based, or VRF. This is the last step for layer 3 tunnels. Okay, just a few words about each step. The first step, when we bring customers, what is the disadvantage first? Of course, disadvantage is that we create large layer 2 domains and the customer can see each other. But we live in a smart world already. Networking technologies are not like in the year 1995. So we can use a Mikrotik no default forward to separate traffic of wireless customers. We can use port isolation on switches, or it's a private VLAN technology called. And we can use, if we have bridges, we can use split horizon there. So, but advantages of this approach. That this approach, as I told, first of all, of course, that it works fine with our VRFs. The second is that we don't need /30 networks, large networks, we can use just /24 for all users connected to the tower. Each customer appears on provider edge as an interface, so we can have customer per customer, and each customer can have different VLAN, and we can put this VLAN to VPLS or to VRF, and we can also deploy different VLANs for different services like voice, internet, and they all will have own routing. And that VRF works fine in that setup. Okay, the step number 2. I activated OSPF in core and distribution, so we have several areas. This is just an example. One area has 136 active roads. So these are roads only connecting the core network itself and the provider edges. So there are no roads about the customer networks. I don't need to put customer networks to my OSPF. I have everything in MPLS, in VRF. I don't put it here. So this is very clear, simple setup of OSPF. And so the next step is LDP activation. When you activate your neighbors, and you will say that they will talk instead of IPv4, they will talk on MPLS. Be careful with that addresses. You must see what you see on my screenshot. If you activate LDP and you do not see addresses on the left, it means that you have MTU issue somewhere between the routers. So many times I got the problem with MTU. I made the LTP, everything looks like it is working, not working, something wrong, but always Mikrotik doesn't show these addresses, it's IPs of provider edge itself, so it doesn't show these addresses properly. So it's empty or it's half empty, so just be careful with that, with the MTU. And MPLS tags. So we see that we have MPLS network working and we have MPLS forwarding, a lot of tags instead of routing information, instead of IP roles, is here present, like 387 on some router. We activated, together with IP, we activated support of other multi-protocol support of BGP, which is VPN-v4 and L2 VPN. We use Mikrotik routers as a route reflector for BGP. So when you need to connect a lot of routers on BGP, and so they need to share information with each other, you can use full mesh. Try it, it will be funny. Or you can use route reflectors. It's one or two routers which are connected to all of routers and they are just sending information between them. And Mikrotik works very well in this field, in this area. We have two route reflectors now, and they are up. We don't have any issues, so I recommend you to use, even if you do not use MPLS, but still you can, you work with BGP, many of you work with BGP, and you will have internal BGP. So for internal BGP as a route reflector, you can use Mikrotik. Do it. And the last steps, as I told, is, so this is true. So this is just a proof that everything what I was telling you now is true, and it's a lot of working tunnels, a lot of working VPLS tunnels. Nothing disconnected, working for weeks, for months on Mikrotik for good money, not as, you know, that company, another one. VRF setup, and this is the VRF setup. Well, the last step, this is just the last step. We have multiple VRFs, we have multiple routing tables for different type of traffic. So this is my table for internet, for voice, and the traffic is routed completely different. I have another table for my ISPs which are connected to me, and I provide the transit for them. So, and it has also another traffic. And also what is nice that together with all this MPLS we can implement traffic engineering, which is not part of this presentation. This technology will give you just more than choosing of different default roles, but you can also say what path you should send traffic and which traffic will be sent through this path. So this is just an example, the second table, the voice table. So VRF is working, just use it smart. Conclusion, prerequisite, if you are going to implement MPLS, please at least go to MTC INE Internet Working Training. Of course, the best is if you come to me, but there are many other trainers also. Advantages, not expensive and solid MPLS solution of Mikrotik is Cloud Core. Use it, but know about some limitations in technology. Fast, reliable layer 2 tunnels, and use VRFs if you have similar setup to our setup. And traffic engineering can be implemented in that setup. Disadvantage is, what we met is just my personal opinion that some setups of layer 3 VPNs are not still stable, but I'm sure that Mikrotik will improve it, because as I see the history how they were improving VRFs, it's already some work was done there. So this is everything. Thank you. Contact me on these emails or here. I'm still in Prague.
Does anybody have any question? Hello? I don't know if it's related to your presentation, but I saw you use DHP to your clients, to provide internet to your clients. How do you do the EEE, authentication access?
Nice, good question. We have Radius authentication for DHCP clients, and unfortunately on Mikrotik, as you know, Radius doesn't send accounting information. You know it, but we use API because I had a software commercial, so many people know me here, and we use our software. So we combine authentication through Radius, and we get accounting from DHCP through API. So this way it works. But it's a small hack. Thank you.
Thank you, Alexander. So this is the time for raffle. Lottery.